This is question 5 on the November 2010 Mod 5 Higher Paper 1. We've got a travel graph and they're going to ask us some questions and ask us to do some drawing on it as well. It says Marcus leaves home at 9:30 to drive to Leeds, 50 kilometres away. Leeds is up here, this is the 50 kilometre mark. He stops at a petrol station on his way to Leeds. Stopping is shown by a horizontal line, so that's this part of the journey here. The first question says, how far has he gone before he stops at the petrol station? The petrol station is at this point here. If you come off over here and read it off, that is at 14 kilometres. Part B, how many minutes is he at the petrol station? Well, if we look very carefully at the scale along here, each of these groups here is worth 10 minutes, and there are 5 squares in 10 minutes. So each square is worth 2 minutes. And at the petrol station there's 1, 2, 3, 4, 5, 6 squares. And if each square was 2 minutes, 6 lots of 2 minutes is 12 minutes. The next part of the question says Marcus stays in Leeds until 11:10. He leaves Leeds and arrives home at 11:50. We have to complete the graph. So 11:10 on the graph is at this marker here. So if I go up that line, that will be there. I need to extend this horizontal line, the stopping at Leeds line, which you can see there. If I zoom out, you'll get that a bit better. So it's level with the 50, and it's above the 11:10. And then it said after that, he drives back to Leeds and gets home at 11:50. Well, this is 11:40, this is 11:50. So I now need to join those up. And that's the travel graph complete for part C1. Then it says calculate the average speed for his return journey. The speed is going to be distance divided by time. The distance of that return journey was 50 kilometres. And the time for that return journey from 11:10 to 11:50 is 40 minutes. So it's tempting to do 50 divided by 40. But that would give me an answer in kilometres per minute, and they want it in kilometres per hour. So I've got to change. I can keep my 50 because that is in kilometres, that's what they want. But 40 minutes is 2/3 of an hour. 1/3 of an hour is 20 minutes. So 40 minutes is 2/3 of an hour. So I've got to do 50, which is a kilometres number, divided by 2/3, which is an hour number. So if you're doing it without a calculator, 50 divided by 2/3, remember the rule is keep, change, to divide into a times, and flip that one upside down. So I'm doing 50 times by 3 over 2. 50 times by 3 is 150. And 150 divided by 2 is 75. So the final answer there is 75 kilometres per hour. The next part of the question, we have a formula T equals dA over P, and we're given 3 figures, a value for D, a value for A and a value for P, and we've got to work out T, the total cost for a year. So we've got to do D times by A, which is 30,000 times by 1.1, and that has to be divided by P, which is 15. We've got to work this out without a calculator. First thing to do is spot that 15 goes into 30. 15 goes into 15 once, 15 goes into 30 twice. So already my question is now changed into 2,000 times by 1.1 over 1. And dividing by 1 makes no difference to anything, so I've got 2,000 times by 1.1. Well, 2 times by 1.1 is 2.2, so 2,000 times 1.1 is 2,200. And that is the answer down here for that question. The final question is a wordy question, no sums involved. It says in the following year Marcus travels fewer kilometres but his total petrol costs stay the same. Give a possible reason. Several reasons for this. One is that the price of petrol has gone up. He could have changed his car. Various other things you could have said as well. But just a real sensible answer will get you that mark.